Good evening, everyone. My name is Manohar. I am from CSCD. My roll number is 21BQ 180514. Now, I am going to discuss Newton rings. This is the experimental setup for Newton rings. The light rays are coming from sodium vapor light, and this is the glass plate which is placed 45 degrees angle. So, the light rays are reflected by this glass plate and the plane convex lens, again here it is reflected back. We can see these Newton rings with the help of traveling microscope. So what is happening here? Let us see with an example. For a normal incident light, it is transmitted and reflected back into an air, and on internal reflection the second ray will be, these two light rays are parallel to each other, ray 1 and ray 2, naming these rays A, B, C and D. The transmitted light, the transmitted ray is reflected by the lower surface of the lens and transmitted into air along ray 1. A part of this ray BC gets transmitted along CD to the upper surface of the glass plate and reflected back and transmits into air along ray 2. These two rays are parallel to each other. These two rays are parallel to each other. So they interfere with each other. Forming Newton rings. The path difference is given by 2 mu t plus or minus lambda by 2. When film between the lens and glass plate glass plate is air, then mu is equal to 1, and for normal incidence of light, R is equal to 0. So path difference is equal to 2t plus or minus lambda by 2. Now the condition for bright circular ring delta is equal to 2t plus or minus lambda by 2 is equal to n lambda. On solving, we get path difference is equal to 2t is equal to 2n plus or minus 1 lambda by 2. This is equation 1. For dark circular ring, two t is equal to n lambda. Let this is an equation 2. From equation 2 and 1, it is evident that the formation of dark and bright ring depends on thickness of air film between convex lens and the glass plate. T is equal along a circle. Hence, we obtain concentric circular fringes with point of contact as center. Now let us discuss the topic how to determine the diameter of Newton's rings in reflected light. So let us draw the diagram. This is the center of the ring. Let us assume that a ring is formed at PQ, center C, and I am naming this point as N. This glass plate L and L dash. Thickness of the air film is T, and this point name is 0, and from here to here the radius is R, and CP is equal to R, and the distance this point is D. OC is equal to CD is equal to R. Let us consider a Newton ring. A Newton ring formed at QP. Let the thickness of the air film between this ring QP is T, and the NP and NQ distance are equal to radius R. NP NQ is equal to R, and CN is equal to CO minus NO. CO is nothing but the radius capital R, and NO is nothing but NO is equal to T. This is CM. From the triangle PNC, PC square is equal to PN square plus CN square. According to the Pythagoras theorem, PC is nothing but R, capital radius, and PN is small r, and Cn is equal to R minus T whole square. On solving, we get R square minus, by using A minus B whole square formula, plus T square. R square gets cancelled, and small r square is equal to 2RT minus T square. Whereas T is far less than from R, so T square is also far less than from 2RT. So R square is equal to 2RT. Let this is the equation number 1. This is an equation number 1. From Newton's rings formation, condition for path difference of dark ring is 2t is equal to n lambda. Substitute in 1. We get R is equal to nr lambda. R is equal to square root of nr lambda. D is equal to 2R, which is nothing but 2 nr lambda. Hence D is directly proportional to square root of n. condition for path difference of bright ring is 2t is equal to 2n plus or minus 1 lambda by 2. Substitute in equation 1, we get r square is equal to 2n plus or minus 1 lambda by 2 r, d is equal to 2r, where r is equal to square root of 2n plus or minus 1 lambda by 2 r. D is directly proportional to 2n plus or minus 1 lambda. So here the diameter of the Newton ring directly proportional to square root of a natural number. As the order of the fringe increases, width of the fringe decreases. In case of reflected light, central ring is dark. Since the condition t is equal to 0 is satisfied by dark ring only. Thank you.